So let's go to new screen. So again, the stuff in parentheses from here, this, no, can't even do parentheses, right? So this part right here, I added it, and it was just for the people who are new to this, to let them know that they were giving you information specifically that you could use to figure out the launch velocity, which you would not have been able to figure out any other way. And you need the launch velocity to do this problem. It is an intermediary step. With this launch speed, would the ball clear a 7.32 meter high fence that is 97.5 meters horizontally from the launch point? And then there's information that's after this, but that's immaterial. That's to get you to think about whether it's going to be below the fence or above the fence. You will get that in the course of solving this problem if you solve it the way I'm going to solve it. There are several methods to solve this question. I'm going to show you the method that I would use because it solves the question. There are other methods to do that don't solve the question, but will get you there eventually. So again, number 6 is the women's volleyball thing. So it tells you all about the serve of the volleyball thing. And the one thing about number 6 that I think is nice is it's a threshold problem. And the AP exam, and is there another one of these I can speak to? Yep.
Number 3, please.
Number 3, I like the basketball question. It's the first one that takes this all and throws it out the window a bit. I expected more people to ask me about it. But I think you guys are kind of accustomed to the fact that if it's early in the homework, it must be the easy ones, and you feel a little embarrassed if you ask. But this is the first question where I didn't give you any of the things you're used to. Yet no one asked about it until last night around 10. Thank you. So, tell us first that the basketball player is jumping and is going to have a maximum delta y of 1.2 meters and is going to travel horizontally 4 meters. And they ask you to figure out what their launch velocity is. So the speed and angle at which they leave the ground. Everybody understand that question? I'm not going to use the information that's here. I'm going to use half of it. They gave me the maximum height, so I'm going to talk about the trip that is from the ground to the maximum height, not all the way back to the ground. Fair enough? Because this is half of the trip, half of the time, I can use this information. Now let's look at what I have. I know that my my delta x is 2 meters. I don't know Vx, and I don't know T. Delta y I know is positive 1.2 meters. I'm going to make upwards positive, to the right positive. I know that Vy initial is unknown. I don't know what it is. But I know that Vy has got to be 0 at the top of the flight. I am at the maximum height. You understand how important that is to me? Why I'm emphasizing it. My voice dropped an octave. I'm repeating myself. And I'm stalling for time to make sure everybody's paying attention here. You reach maximum height when the final velocity is 0. That's a piece of information. I have enough information to figure out how long it takes them to get to that height. I have 3 pieces of information, which is all I need. So I now know how long it will take them to get up to that maximum height. So let's do that real quick. Let's figure out how long it's going to take them to get up to that maximum height. I'm thinking 1.2 equals 0 times t minus 1/2 times negative 10 t squared. Right? So how long does it take for them to get up to that height? Yes, sir? Half a second. That's good. Half a second. Now, here's the thing. That must mean their sideways velocity is 2 divided by 0.5, or 4 meters per second. Now, this doesn't tell me their initial y velocity, but I still have all of these things. I can still figure out what their initial y velocity is. 0 minus Vy naught squared equals 2 times negative 10 times 1.2. Any question about where this is coming from? All right, good. So what is their initial y velocity? Plus or minus what? I can wait. Square root of 24, though. 4 point what? 4.9. Which one of these do I choose, the positive or the negative? Do they jump up or do they jump down? Yeah, so I'm going to choose the positive. Makes the most sense. They're not burrowing into the ground. So since I said up is positive, I think they jump up. There we go. Now, this is not the answer. However, they jump at some angle with some velocity. And the horizontal part of this has got to be 4. And the vertical part of this has got to be 4.9. Right? I'm just doing this backwards. I think you can figure it out now, right? I hope so. I hope you're paying this kind of attention. There's every reason to believe I could ask this question on the test. It's no different than what you've done. It's just in the other direction. Do I need to go any further here? Because the next question isn't this at all. In fact, you didn't have to do any of this for the next question. So the next part is about time. How long are they spending in the air? And they want to know how long do they spend in the upper half and how long do they spend in the lower half. And no, it's not half the time in each of those. They spend less time in the lower half than the upper half. That's why they look like they're floating when they go to a dunk. So the real question is, how do you figure that out? Believe it or not, we didn't need any projectile motion stuff to figure this out. Because to figure it out, we only care about the fact that they're going up and down. So I'll put that over there for a minute. And this is how I would do it if I was to drop something from a height of 1.2 meters. Could I figure out how long it would take to reach the ground? Do so. I'm going to drop something, and it's going to fall 1.2 meters. Thank you so much. You too. Can you tell me how long it would take to reach the ground? And then when you're done with that, I want you to drop something from 1.2 meters, but tell me how long it takes to fall 0.6 meters. You got two problems to do now. I can pick on two people. So this side of the room, concentrate on the 0.6 one. This side of the room, concentrate on the 1.2 one. And then I'll pick one from each room, or each side of the room. Gotta hurry, bell's gonna ring soon. Hurry, hurry, hurry. I know who I want to call on. I know who the people who are not gonna do it or struggling. They should be sweating and shaking just like they were holding the marble yesterday. This is not a quadratic or nothing. It's super simple. You're taking the square root of, well, we talked about the other day, 2h over g, but. All right, Tyler, what is this one?
Half a second.
Give me a decimal.
0.494.
0.494 seconds. Good. And, I don't know. Lorena, can you give me this one? Okay. But I want somebody. Jack, can you give me this one?
I got 1.24 seconds.
1.24 seconds?
Yeah.
Okay. Now, bear this out. If I want to know how long it went from here to here, I just have to subtract, right? But there's a problem here. It can't take longer to fall this distance than it does to fall this distance. So I believe we have an issue. You follow me, right? So we're going to have to do something. And the bell's ringing soon, and I'm nervous. I'm not sure I have confidence in any of these numbers now. I'm confident in this one. I'm confident in this one. I am unconfident in this one. Come on, how long does it take to fall 0.6? Yes, sir? I don't know. I'm asking you these. But that sounds much better. 0.35 seconds. Now, folks, come on. Stay with me here. I don't want to lose everybody. It must be 0.49 minus 0.35 is the time it takes to fall the last half. You understand what I'm saying? Now, these aren't the answers. It takes 0.35 seconds to fall the first 0.6 meters, which means it must take 0.7 seconds to go up and down 2 times that time. Oh well. I am going to check your abilities on Monday. I actually like figuring out whether you have an understanding of a threshold. So we're looking at a court, and let's see, you have to help me out here. This is 9 meters is where the line is. And although this side also has to be 9 meters, they're saying that the person is serving 8 meters away. So 8 meters away from the edge of the court, and they're about to hit the ball. They're probably higher than that. They're about to hit the ball horizontally, is my understanding, and they will hit the ball when they are 3 meters from the ground, and the net is 2.24 meters. And the question asks, at what velocity do they have to hit the ball so that they clear the net, and what velocity can they not exceed before it goes out? So you have to kind of do a little imagining here that if you hit the ball too slowly, the ball will fall beneath the net. And of course, that's obviously too slow. I gotta make the net a little smaller. So then there's the possibility that you do hit it fast enough so that you just clear the net, but then you'll land somewhere like here. And then there's a possibility that you could hit the ball fast enough to not only clear the net, but land right here. Any faster than that, and you'll be out. Suggesting that there's a minimum and a maximum range of velocities that you can use. You have to be fast enough to get over the net, but slow enough not to be out. Does that make sense? All right, so that seems to be two different questions. There's a question about what it would take to get over the net, and then a question about what it would take to stay in bounds. So let's consider the first version of this question. The first version of this question is what it takes to go over the net. So I'll do a vertical and horizontal here. Delta y, vy naught, vy, at. And this side, delta x, vx, and t. Luckily, this problem is a little bit simplified for us. The initial y velocity is 0 because they say they're hitting it just horizontally. We don't know vx. In fact, it occurs to me we're looking for a velocity, so we must be trying to solve for vx. Now, in the first scenario where I'm looking at how fast do I have to hit it to get over the net, I have to make it horizontally 8 meters to the net. And in that time, the ball can only drop a distance of whatever 3 minus 2.24 is. And I'm making it negative because I'm going to say that upwards is positive. So I find the separation distance because we are 3 meters above the ground and we don't want it to go any further than this distance. I think that's 0.76. But I wanted to make sure that I answered the question, where did you get 0.76, Mr. Shelton? So there it is. Acceleration is still downwards at negative 10 meters per second squared. So I think I have enough information to figure out how long it's going to take for the ball to drop that distance, and therefore how fast it has to be going to make it sideways 8 meters in that time. Everybody follow that? Do I need to continue? Now, your answer should not be Vx equals. Your answer should be, this is the minimum velocity to be in, and it better be greater than whatever this number is. Not equal. If you know the rules of volleyball, you hit the net, it's not in. During a serve, it has to go over the net cleanly, I believe. So it better be faster than this. Now we're going to reset the problem because the second problem isn't about the net any longer. Pretty sure we're going to be going faster than this. But our second problem, the ball has to make it 17 meters, right? 8 plus 9 has to make it all the way to here. Hello.
Did you want me to do the paperwork again for the dues?
I can't find the receipt, so either Alexis has it or it didn't get paid. I assume if we pay it second time, it'll just be next year's. So this is another one of our bills.
Okay, so I'll take care of.
Thank you. Hey guys, teacher of the year right here.
No, it was him.
No,
as
no.
far as I'm concerned,
Nope, it was you. I voted for you.
I voted for you. I'm not kidding.
I'm not kidding. Oh well. But Chef Phil won, so it's okay. We like Chef Phil.
He does great with those kids.
Yeah. All right. Mrs. Smith, I think she's a rock star. What do you guys think?
She's awesome.
She is awesome. And she's kind of quirky. I like that.
Yes, she is.
So delta y, 3 meters, right? It's going to make it all the way to the ground. The rest of the problem is exactly the same. We're going to find the velocity that'll get us there. This time, though, this is our maximum velocity, not the minimum. You can't go any faster than this. But you can go this fast, but you can't exceed it, right? Because it can land on the line in volleyball and it's still in. I know the rules. So is that enough for this question?
Yeah.
Okay. So I don't remember any of the information from the problem because I'm just not doing that apparently. So we are starting 1.22 meters above the ground, and this is not going to be drawn on the scale. It is hit at an angle of 45 degrees. And that's all we know, except that it makes it back to that same position. How far away? 107 meters? 107 meters away. It is at the same place. Now, we don't know if that's on the other side of the fence or not, so I should draw that further away. The fence is only 97 meters away. Right there. So, all same height, right there, going this way. But we would like to know if it clears a fence that is located 97 meters from where it was hit. And how high is the fence? Because I don't remember that part, 7 point something. 32? All right. So we don't know if it clears the fence or not. So first, let's figure out the launch velocity of the ball. That's why that information was given. That's the range equation. And later on, maybe not today, but maybe Monday, I'll show you why you can't figure out the velocity from the ball any other way. So this will be V naught squared sine 2 theta over G. And we have everything we need to do this. The sine of 2 theta is just 1, so I don't think I have to sweat that because they told me a launch velocity of a launch angle of 45 degrees. So do I have to spend much time on that or expend any energy explaining why that means the sine's going to be 1? Okay, so 107 equals V naught squared over 10. So V naught squared is V naught is plus or minus the root of 1070. I have no idea. And I'm going to choose the positive root because that makes the most sense here. So nobody did this question. So when I sent out the thing about I'll accept the homework on Monday, everybody just put their pencils down, huh? It was 10:30. That's nice. It's probably should have. Or was it 9:30? I don't remember. I was just done answering remind requests.
The velocity, 32.78.
All right, so you should use 32.78. I'm going to use 33. Now, the next question is different, meaning I've got the velocity now. I'm going to ignore all of this and set up a new problem, a projectile problem. And this is our attempt to see if the ball clears the fence or not. And a lot of people attack this problem differently than I'm going to attack it when they're doing it for the first time. There's a bunch of you in the room who are going to use what we've been doing to figure out where the ball lands. That doesn't help you. Knowing where the ball lands doesn't tell us if it clears the fence or not. So if you attempt to find the range, this could be a possible thing. You'll get a range, but what does that tell you? It does not tell you if it clears the fence or not. You need something that tells you whether you've cleared the fence or not. So what I'm going to do is I'm going to assume the ball makes it horizontally 97.5 meters. I'm going to make that assumption. It might not. It might hit the dirt, but we were already told it went 107 meters and was right back at the same height. So it's very likely to make it this distance. I know how fast it's moving horizontally. We have that now. 33 cosine 45 degrees. 32 point something cosine 45 degrees. Which means I can use this to figure out how long it takes to make it to the fence. No quadratic formula. I can get the time directly. This is how long it's going to take it to make it 97.5 meters horizontally from where I started. You're right? That's right. Nosebleed?
Yeah.
Right. Maintaining this, delta y, vy initial, still going to be 33 sine 45. Acceleration, negative 10 meters per second squared. I'm still going to go with the upwards is positive thing. And we're going to receive the time from here. Now, what I would expect you to do at this point is use this to figure out delta y. Oh, thank you, David. We know that the ball has to go a delta y great enough to get us from 1.22 meters. We have to have a delta y that's great enough to get it. So, your job here is to figure out whether the ball has a delta y that is great enough to make it to 7.32 meters. You're at 1.22 meters, so the delta y has to be, what, 6.1 meters? You need to figure out delta y and see, is it greater than 6.1? That's our question. If it's greater than 6.1, it clears the fence. If it's not greater than 6.1, it doesn't. Well, so I didn't record any of that, so oh well. You guys who are just tuning in right now because you were absent today and you wanted to know what happened in class, I just went through everything that was necessary to solve this problem, and I'm not going to repeat it because I just don't feel like it. But I will talk about the second part of this problem because I have to. I'm not going to solve it, though. I'm going to just go to the next part of the problem. Are we good for that? Now, the thing about threshold values, and I would encourage you to understand that we will deal with threshold values all the time, is that your answer is not going to be equal to. When you finish this, you're going to get a value for Vx, but you know that your actual horizontal velocity will have to be greater than this threshold value. If it's at this threshold value, it hits the net and therefore didn't clear the net. You must go faster. In a few minutes, we're going to get a value as well, but we need to be less than that threshold value. Because if I'm at that, well, although hitting the line is in volleyball, so I guess I'll get the less than equal sign. Now, you don't need to know the rules of volleyball, but it will probably be helpful, so we can be authentic. So I'm going to change this to -3. So the ball's going to travel all the way to the ground. But I also have to change this from 8 to 17 because now it's going to go all the way to the back of the court and repeat. All right. Oh, that was fun times. Fun times. Oops. It was unsuccessful yet again. There. All right. I just can't draw today. Maybe it's because I'm just tired of doing projectile problems. There we go. So we'll put your friend up here. Whee! And we'll start here and just indicate that we are doing 40 degrees. This is 4 meters. And what is the speed? 18 meters per second? All right.
miles per hour. A little kid kicking the ball at 40 miles per hour is crazy to me.
I don't know. What's your kick speed?
The average pro in soccer.
What is your kick speed? I don't know either. So I didn't want to use 5 because I needed to make sure it goes 4 meters high.
70.
Okay.
I looked it up last night because I was impressed by this little kid.
Yeah. All right, so I'm not going to redraw this a bunch of times, but probably the way I've drawn it now, I'm looking at the longer distance to get there. Meaning we're looking at the time where it goes like that. Now, we're trying to figure out when the ball will make it this horizontal distance, to the building. But we don't know what this horizontal distance is. So we do know that we have to be a certain height. That's important. So I'm going to set up my chart. And we are looking for this. We don't have that. We have that delta y has got to be positive 4 meters, assuming upwards is positive. Right? The ball has to be 4 meters above where it's launched. I know that. And then my initial y velocity, 18 sine 40 degrees. This is prescriptive. I don't have to think about this very much. They gave me a launch velocity and a launch angle, so it's just a prescription. Vy, don't know. Acceleration, 10 meters per second squared. I'm choosing to make sure it's downwards. And I'm kind of at the very bottom of the screen, but you know that we're going to solve for t. And you're not going to be able to see that because my screen is not perfectly lined up. Now, before you even launch into it, there's two answers here. Has to be. I suspect if the ball can make it 4 meters above the ground, there will be a time when it makes it 4 meters above the ground on its way up, and a time when it makes it to that 4 meters mark on the way down. You have to figure out the times. Now, I've discovered over the course of today that there are students who just can't do this in my AP1 class. You're my first AP mechanics class. I don't want to discover this. What I mean by that is there's two methods that you can use that involve your basic, algebra skills. I'm supposed to be able to count on them. And the fact that this is part of our class is a little bit of a disappointment because being able to find these two roots really has nothing to do with physics. Understanding why there's two roots, that has to do with physics. But you have to get both times here. And some of you can't. You need to work on that. I can give you another method to figure out the time that doesn't use the quadratic formula. Do you need that? Because I'll be happy to go over it. So here's what we're going to do. You're going to prove this. You have 60 seconds to show me what both times are. I've gone all the way to the end of setting up a quadratic. There's a variety of methods you could use here, including the polynomial root finder built into the TI calculator by choosing apps and going down to Polysmith or whatever it's called, and then go to the next part where it's polynomial root finder. It will solve it right there without even graphing it. It's very straightforward. I didn't even know it existed until first period. So now you know. Apps, poly something. There is somebody at your table who probably knows. Ask them. But you still have 40 seconds to figure out the two times. So look, I don't know how to, it's really hard to communicate this to you guys because you're so grade thirsty. But finding the two times is going to take longer than the point value from which it's worth. They're only going to give you, at max, you're going to get a point if this is on the AP exam. At maximum, a point. So your ability to find the time, though, you can't take a minute for that because it's probably more likely that you're going to have to do something else with that time, and that's what's going to be worth the point. But it's one of those things that takes a long time for some people. So if you can find a method that just pops it out of the calculator, do it. You just have to have faith that what you're getting is the right answer. You can check, right? But that takes more time. Either way, somebody give me the two times. 0.4, I think. And what's the other one? 1.8? This has nothing to do with physics. This is a property of mathematics. You get these numbers from making sure that the plus signs and minus signs are all correct here, and for making sure your calculator was in degrees when you calculated the velocity. None of this is physics. But understanding why there's two answers, that's some physics right there. And it's knowing that there's two different times when it's 4 meters above the ground. And that also means two different horizontal distances. Because it should be pretty clear that he could be standing there. And that's why there's two different ranges. That understanding, that's the physics part. And why one of those times doesn't have any more value than the other. Now, if we needed to land on the roof, you would have to choose the larger of the two times. The velocity would have to be downwards. You can't land on a roof while you're going upwards. Understand the difference? This is about not physics or math. It's about interpreting what's actually happening in nature. So the guy can catch the ball when it's on the way up, but it can't land on the building when it's on the way up. The rest of this is finding the I put a question mark in Vx, but we actually know Vx, don't we? 18 cosine 40. So there. I don't know what's going on. I could be wrong. So is there any more to this problem that you think we need to discuss? Is there a different homework question you would like me to discuss?